David Smith here with one more flipped classroom math video. 3 tips before we start. First, remember you can speed up the playback if that helps you get through the video faster. Just make sure you understand and keep up with your notes. Second, you can pause the video at any time to catch up with your notes or think about the topics. Lastly, you can turn on the captions and watch my words go by on the bottom of your screen. Today's lesson covers using the cosine rule to find angles in non-right triangles. So quick review, cosine rule works for a triangle labeled like this, where we have our angles labeled with the uppercase letters A, B, and C, and then the side lengths are labeled with the lowercase letters in a certain way that little a is across from big A, little b across from big B, little c across from big C. Okay, so to review, the cosine rule says that a squared, which would be the length of that side squared, is going to be the squares of the other two sides minus 2 times those other two sides times the cosine of angle A, which is back over here. So one way to look at that helps make sense of it is that the little a is on one side and the big A is all the way over on the other side. And you know that we have two other versions of this rule where we have b squared equals all these things ending up with cosine b, and we have c squared equals all the other things times cosine c. So that's the regular cosine rule, and we've used that to find sides in non-right triangles. Now, just like with SOHCAHTOA trigonometry and like the sine rule, we can use this rule also to find angles. And so that rule is written this way. I'm not going to drag you through all the algebra steps, but basically what we did to get this is we just took this rule and we solved it for cosine A, and then we took the inverse of that to get angle A. So here we go. It's cosine inverse of b squared plus c squared minus a squared over 2 times bc. And that's going to give us angle A. Now, that's a lot of stuff, a lot of algebra in there, a lot of plugging in and solving. But once you practice it, I'm sure you can get that. So let's do an example. Here I have a triangle. It's labeled pretty similarly to that one. We have our triangle A, B, C, and you've got 3 sides, 16, 21, and 18. So what I want you to do first is pause the video, use this triangle to do a plug-in step with this rule here. This is set up to work pretty closely with the way I've written the rule there. So pause the video and give that a shot. All right, let's see how you did. Here's what I get, is I get cosine inverse of 21 squared plus 18 squared minus 16 squared over 2 times 21 times 18. The inverse of all of that math, take the inverse cosine of that, and that will give you angle A. So now I want you to give that a try. All right, so let's see how you did. When I crunched all of these numbers, everything here in the parentheses, I got 0.673. Then I take the inverse cosine of that, and I got 47.7 degrees. All right, let's do another problem. Notice how I put our diagram over here. Here's our cosine rule and the figure upon which it's based. But now notice something. I haven't given you any letters. All I've done is given you 3 sides and the angle to find. So your plug-in step is going to be a little bit more challenging. So go ahead. I want you to pause the video and give that a shot. Do your plug-in step for the expression that will help us find theta. All right, let's see how you did. So here's what I get. I got cosine inverse equals 178 squared plus 219 squared minus 207 squared over 2 times 178 times 219. It's the inverse cosine of that. Now, it can be kind of easy to get a little messed up, so I want to point out some things just to see. The 2 sides that bracket the angle you're after come first. The side opposite of the angle you're after comes last. And then this is just 2 times the same 2 sides that you squared on the top. So that's one way to think about it. If you need, you can always just refer to the rule and orientate yourself to the triangle that you have to figure out how to do that plug-in step. Now I want you to pause the video and do the math on that and find out indeed what theta is. All right, so when I crunch the numbers, I put all this into my calculator, and I can do all of that without writing anything down. And I come to this point where I write down my decimal. And I'm putting in 3 decimal places in here because that's going to give me a better angle, a better approximation of the angle. So when I do all that number crunching, I get 0.472. And then when I take the inverse cosine of that, I get 61.8 degrees. All right, let's do a more complicated problem that's solved by using the cosine rule, okay? At least one step of that. So I want you to take a look. I've given you a triangle, ABC here, and I've marked my sides with the numbers for their lengths. But now I'm asking you to find the area of this triangle. So it's going to take a little bit of critical thinking to figure this out. I want you to pause the video and just come up with a plan. Think to yourself, make some notes. What would you do with this information in order to find the area of that triangle? Okay, let's see how you did. So first off, we know that we can find the area of this triangle with the area formula that uses sine. And that's the way to do that when you don't know the height. And we don't have a height for that triangle. We might be able to figure out the height another way, but let's use the tools that we're working on in our current chapter. So we know that we can find the area of this triangle using that formula, but it needs an angle. We have to use sine because that's that formula. It's 1/2 base times height times sine of the angle. So I don't have an angle. So this is where the cosine rule comes in. I need to find an angle in this triangle. And this I can use the cosine rule for. So what I'm going to do, 2 steps. First, I'm going to use the cosine rule to find an angle in this triangle. And then I'm going to use that angle with 2 of the sides to find the area of the triangle. So what I'd like you to do is pause the video, pick an angle that you want to find. It could be any one of the 3. And go ahead and find that angle. All right, so I decided to find this angle. Just for whatever reason, that's what I picked. So to find that angle using the cosine rule, I'm going to take the inverse cosine of the squares of the 2 sides that are next to my angle, just like last time. So that's 1.9 squared plus 3.5 squared. Then I'm going to subtract the square of the side opposite the angle that I want to find. So that's minus 2.3 squared. And then I'm going to do the bottom part, the 2AB. So that's 2 times 1.9 times 3.5. So this is my plug-in step to find my theta in my triangle there. So go ahead and pause the video and run that through your calculator. All right, so I crunched the numbers in there. I did that on my calculator. I wrote down my 3 decimal place decimal for that big old massive fraction. And then I took my inverse cosine of that, and I got 37.4 degrees. I'm going to take a look at my picture. Yeah, that's reasonable. This angle looks like it could be 37 degrees. It's certainly not like big, like an 80-degree angle or something. So this answer passes the reasonableness test. Great. Now that I know theta, I can write an equation with the triangle area formula to find the area of this triangle. So pause the video, perhaps look back through your notes and find that formula and do a plug-in step. All right, I just checked back in my notes and I came up with this little diagram to help refresh you here. Here's our triangle, same kind of diagram as this one. In fact, I probably didn't need to draw it again, but there you go. And the area formula for a triangle is just 1/2 AB sine C. So it's 1/2 the 2 sides and the sine of the angle in between them. So the area of this triangle is going to be given by this. Area equals 1/2. Now it's AB, which are the sides connecting the angle. So here's the angle that we know. That's our 37.4. So it's going to be 1/2 times 3.5 times 1.9 times the sine of 37.4 degrees. So that's my plug-in step. Go ahead and pause your video, get out your calculator, and do that calculation. All right, here's what I get. I plug in all this information, do it on my handy calculator, and I got the area of this triangle is 2.02 units squared. I didn't give you units for this, so all you can do here is just say units squared. Now that you've watched the video, take a moment to write down any questions so you can bring them to our next class. Always remember, you can watch the video again to deepen your understanding. If you enjoyed the video, please click like and subscribe.